In video segment 3, we describe the transformation activity we mentioned earlier, and we also include a timeline. The transformation activity is the last instructional activity in part 1 of the coordinating unit sequence. In this activity, children are asked to think of different ways they can have a given quantity of candies. Here's an example. Mrs. Wright has 43 lemon candies. Some of them might be packed up in rolls, and some of them not yet packed up. Maybe none of them are packed up. Maybe they're all packed up. How many rolls and how many pieces might there be? Draw pictures to show different ways she can have 43 candies. Come up with as many different ways as you can. Children work individually on this task and have paper and pencil to record the ways they think of. After they have enough time to complete the task, there's a class discussion. The purpose of this task is to create a situation in which students conceptualize a given quantity in terms of rolls and pieces in many different ways. In particular, while it is typical for students to think of a quantity of 43 candies as 4 rolls and 3 pieces, sometimes called the canonical form, or as 43 pieces, the goal of this activity is to elicit other ways as well, such as 3 rolls and 13 pieces, or 2 rolls and 23 pieces, or 1 roll and 33 pieces. For children to have a deep conceptual understanding of place value, it is imperative that they extend their thinking beyond the 2 typical ways to include these others as well. Let me make a pragmatic point here. Some children will complete the task quickly, while others will take much longer. Those children that complete the task quickly can be given another task, another number of candies. They can turn their paper over and complete this task on the other side. Each child should always have some meaningful mathematical activity to engage in at all times during a lesson. They should never be idle, just waiting around for others to complete a task. Of course, the class will discuss only the task that everyone worked on. Many teachers have told us that they find it difficult to explain this task adequately. One way to introduce it is to explain that for each flavor of candy, Mrs. Wright keeps a bin or a tub for rolls and another bin or a tub for individual pieces. So for cherry candies, she has 1 bin for rolls and 1 bin for pieces. For lemon candies, she has 1 bin for rolls and 1 bin for pieces. She has this for every flavor of candies. When the workers first make candies, they put all of them in the pieces bin. When they have time, they work at packing up the candies. When they have a roll packed up, they put it into the rolls bin. So when Mrs. Wright comes to see how many candies of a certain flavor she has, there might be some in the rolls bin. These are the ones that have been packed up, and some in the pieces bin. These are the ones that have not yet been packed up. Now pose the specific task for children to work on. Mrs. Wright's workers made 60 candies. Draw pictures to show different ways to have 60 candies. Come up with as many ways as you can. Let's take a look at what children do. The drawings themselves are quite revealing. Here you see 2 children's drawings for the task. Draw different ways you can have 60 candies. If we look carefully, we can see that Lindsay has drawn 5 rolls and below them 10 pieces of candy. Significantly, to draw the rolls, she did not draw one thing, but clearly drew 10 different pieces that are connected to each other. Lindsay's drawings show that she was trying to make her picture look like Unifix cubes. Children that make drawings like she did typically think of a roll in terms of the ones, the pieces, that comprise it rather than as a single entity in and of itself. Amber's picture, on the other hand, shows a roll as a single entity in her drawing. The first way Amber drew showed 6 rolls. The drawing below that one shows 2 rolls surrounded by 40 pieces. Without having the opportunity to watch her create the drawing or to ask her, we do not know exactly how she proceeded. But I have seen children create such drawings by first drawing the 2 rolls and then counting on from 20 by ones, 21, 22, 23, all the way up to 60 as they draw the individual pieces. Such children typically do not know how many pieces they have drawn. If we were to ask them, they might need to go back to count the pieces by ones, 1, 2, 3, and so on, all the way up to 40 to figure out that they have 40 pieces. Contrast these drawings with Lucas's drawing, shown on the left. Lucas used a single line to indicate a role. We can infer that Lucas thinks of a role as a single entity, one thing. In fact, rather than drawing a picture of a role, Lucas drew something to represent a role. He drew circles to show the individual pieces, but interestingly, he has them arranged in groups of 10 and even has a loop around each group of 10. Without having the chance to ask him, we do not know how he was thinking. Was he thinking that each group of 10 pieces could be packed into a roll? Or maybe that he unpacked a roll to get those 10 pieces? In any event, his drawing reveals a different type of organization from Amber's. For example, if we were to ask Lucas how many pieces he has in the second way he drew, he would most likely very easily say that he has 50 pieces. He might say 10, 20, 30, 40, 50, or simply 50, but he almost surely would not count the pieces by ones from 1 to answer our question. Griffin's paper shows all of his work for this task. We can see that he was systematic in his drawings. First, he shows 6 rolls, next 5 rolls and 10 pieces, then 4 rolls and 20 pieces, 3 rolls and 30 pieces, 2 rolls and 40 pieces, 1 roll and 50 pieces, and 60 pieces. These drawings are clearly marked off from each other, and in each case, he drew the pieces in a column of 10. While his drawings were systematic, indicating quite sophisticated reasoning, the way Griffin drew the rolls indicates that he was still thinking very much in terms of the rolls in Mrs. Wright's candy shop, unlike Lucas, who drew a single line to represent a roll. What I want to convey by showing these children's drawings is the variety of sophistication that presumably reflects the way the child is thinking about the task. We know that as students work on tasks of this type, several shifts in their reasoning might occur. One shift is from creating different arrangements of a given quantity as unrelated configurations of rolls and pieces to viewing each arrangement as the result of a transformation from a previous one. We can see another shift in the type of justification students give as they explain their results to the class. For example, initially students might justify their way of showing the quantity either by counting their collection to verify that it is the given quantity, or by describing how it can be packed up to be in the canonical form. In this case, the justification is based on empirical reasoning. For example, if a student answered 3 rolls and 13 pieces as a way to show 43, he might count the rolls as 30 and then the pieces, 31, 32, all the way up to 43, for a total of 43. Or he might reason that 10 pieces of the 13 can be packed into a roll, yielding a total of 4 rolls and 3 pieces, the canonical form. A shift in reasoning is indicated when students reason that a configuration has to be correct because it is equivalent to a previously agreed upon configuration. In this case, the justification is based on logical reasoning. Here's an example. If the class has already agreed that 3 rolls and 13 pieces is one way to have 43, a child might justify his way of 2 rolls and 23 pieces by saying, if we have 3 rolls and 13 pieces, we can unpack one of the rolls to yield 2 rolls and 23 pieces. Notice that in this example, the child reasoned that his way is correct because it is quantitatively equivalent to another way that we have already agreed was correct. Another shift we have observed frequently is from drawing pictures of rolls and pieces to using numerals to indicate the number of rolls and pieces. In particular, students often make this shift when the number of pieces in their configuration is large. For example, if a student wants to show 1 roll and 33 pieces, it is time-consuming to draw all of the 33 individual pieces. Further, when the student later wants to report what he has during a subsequent class discussion, he might have to go back and recount the pieces to find out that he has 33. Of course, some students will just know that they have 33 pieces because of logical reasoning. Again, these differences in students' ways of reasoning and explaining reveal advances that some of them have made. A goal is that students are able to reason about the quantities without having to count them one by one. Xavier's paper, seen here, shows an example of making a shift to using numerals. Xavier's paper shows that he started by using drawings, but when the number of pieces became large, he shifted to using numerals. He was systematic in the way he drew the waves. Our experience is that for children to shift to using numerals in the way that Xavier did, they have to already know how many pieces there will be in the way they want to show. For example, here Xavier knew that he needed 33 pieces to accompany one roll. The transformation task is appropriately used for several lessons, with 1 or 2 tasks per lesson with a thorough discussion of each task. We remind teachers that our goal is not that they become proficient at the activity. Rather, these activities are designed to promote conceptual development. So we caution teachers to not use an activity over and over until students get good at it. Rather, the teacher should pay attention to how children reason and to the shifts they make in their reasoning. We can see from the differences in Lindsay's work and Lucas's and Griffin's work that there are big differences in their conceptual understandings of tens and ones. With this in mind, the teacher might decide to use the transformation activity once or twice later on in the sequence, perhaps while already using activities from part 2 as a way to give Lindsay an opportunity to reason about transformations, after she has had more experience with using the Unifix cubes to solve problems posed in the candy shop setting. A typical lesson at this time in the sequence might begin with 2 or 3 candy flash tasks, followed by several transformation tasks. The limiting factor about how much to include in a lesson is how much time is needed for thorough discussions of the tasks used. Here we show the general timeline for the entire coordinating unit's instructional sequence. Activities in part 1 of the sequence involve reconceptualizing a quantity by shifting between units of 10 and units of 1. Part 2 of the coordinating unit sequence is designed to develop children's becoming efficient with reasoning about sums and differences by coordinating units of tens and ones. The activities in part 2 involve changing the quantity by either increasing or decreasing the initial amount. As the timeline shows, we recommend devoting approximately 3.5 weeks to part 1 of the sequence and approximately 5.5 weeks to part 2 of the sequence. Now let's take a look at the detailed timeline for part 1. There are 5 activities in part 1. They are introducing the candy shop scenario, packing candies, circling candies, candy flash, and the transformation activity. Some activities will be used only once or twice, while others will be used often. The overlap in the timeline indicates that we intend that some of these activities be used together within the same lesson. The scenario is introduced one time, but many teachers review it briefly for a few days to ensure that it is familiar to everyone. The intention is that the packing candies activity be used only one time. We recommend spending 1 or 2 lessons, but not more, on the circling candies activity. However, the next instructional activity, Candy Flash, is used productively for many weeks, including in combination with activities from part 2 of the sequence. Candy Flash can be combined together with circling candies in the same lesson. The transformation task is appropriately used for several lessons with 1 or 2 tasks per lesson, with a thorough discussion of each task. A typical lesson at this time in the sequence might begin with 2 or 3 candy flash tasks, followed by several transformation tasks. The timeline also shows an activity called Money Flash that is described on the website. We include it in this timeline because it complements part 1 of the coordinating unit sequence. Our recommendation is that this activity be used along with the coordinating units sequence as shown here. Here's a note to teachers. Materials that can be used to introduce the candy shop scenario and the candy flash activity, as well as materials for the circling candy activity, are available on the website.